So in this video we are going to revise the topic of periodic table. So for watching this video you must have a periodic table. So how the elements are arranged? Elements are arranged in the ascending order of their proton number from left to right. From left to right. For example, you can see in the periodic table, hydrogen is the first element because the proton number of hydrogen is 1. And if you are going from left to right, you will see at the end helium. The proton number of helium is 2. So elements are arranged in the ascending order of their proton number from left to right. Second, you can see two types of rows or period. First is group. Vertical columns in the periodic table like this. These are called groups. And how we can decide the group number of element? Number of outermost electron. You can also say number of valence electron in the number of valence electron of that element. If there is one electron in the valence shell, that element will be in group 1. You can see any group. For example, you are taking one member from group 2, that is magnesium. Why magnesium is in group 2? Because it has 2 electrons in the outermost shell. Why chlorine is in group 7? Because it has 7 electrons in the outermost shell. Why neon is in group 8? Because it has 8 electrons in the outermost shell. For example, now the second is we can decide the charge on an element if you know the group number of that element. For example, look at the periodic table. Group 1 element, sodium, lithium, they have +1 charge because they have 1 electron in their outermost shell and they can easily lose that electron. Any member from group 2, you can see the periodic table. Magnesium, calcium, they have +2 charge. Group 7, halogens, they have 7 electrons in the outermost shell, so they just need 1 electron to gain. So the charge on group 7 members, that is 1 minus. Group 8 is they have complete outermost shell, so the charge is 0. Now, how we can decide the group number of an element? Just look at the outermost electron in that element. Second one, what are periods or period number? Total number of shells in that element. And keep in mind, chemical and physical properties are not same in the same period. But in case of group, the chemical properties are same but not the physical properties. Now you can see these types of questions in the chemical paper. For example, list is given, there are some elements, their electronic configuration is given, and these are the question. Elements in the same group, what is the end? They must have same outermost electron. So if you look at element A, it has 2 electrons in the valence shell, and element E, it has also 2 electrons in the valence shell, so they are in the same group. Second question, element which can form 1 minus charge. 1 minus charge means there must be 7 electrons in the outermost shell. So look at element C, it has 7 electrons, it needs 1 electron to complete its octet, so the charge is -1. So the answer is C. Third question, a noble gas. A noble gas means group 8 member, the element which has complete outermost shell. So this is F. Look at element F. It has 8 electrons in the outermost shell. So the outermost shell is complete, octet. So this is F. The fourth question is element which can form +3 charge. What it means? It must have 3 electrons in the outermost shell, and this element is B. B has 3 electrons in the outermost shell, so it will lose these 3 electrons and the charge will be 3+. Fifth, element showing same chemical properties. What is the hint? They must have same valence electron. Keep in mind, the chemical properties depend on the number of outermost of valence electron. So A and E, because A and E both have 2 electron in the outermost shell, it means they are in the same group, so they have same chemical properties. So these are the typical question. Now metallic and non-metallic character in the periodic table. So what is metallic character? Ability of an atom to lose electron. And definitely when the atom will lose electron, it will form cation, or you can say positive ion. It decreases from left to right. That's why you can see metals on the left side of the periodic table or in the middle of the periodic table. On the extreme right, there are non-metals. And the metallic character, it increases from top to bottom. The next is non-metallic character. It is the ability of an element to gain electron. And when an element will gain electron, definitely it will form an anion. And it increases from left to right. That's why you can see non-metals on the extreme right of the periodic table. And from top to bottom, the non-metallic character decreases. Now we will discuss 3 groups in details. One is group 1, the other is group 7, that's also called halogen, and the third is noble gases, and also the fourth one, transition metals. So group 1 metal, the next name for this group is also alkali metals. They are in group 1, so they have just 1 electron in their outermost shell, and if the electron is 1, definitely they can lose that electron, and elements in the group 1 will have 1 plus charge. They are metals, and now some of their physical properties. The melting point decreases from top to bottom. These points are just restricted to group 1. Keep in mind, the density increases, the boiling point also decreases, and they are very soft metal, and they are so metallic bond is weak. Now why the metallic bond is weak in group 1 metals? Metallic bond depends on the number of electrons in the valence shell. Group 1 have just 1 valence electron, so that's why they have the weakest metallic bond. I'm talking about just group 1, and that's why they are very soft metals, and they can be easily cut with knife. Now we will discuss some reactions of this group. They are reactive metals, and the reactivity decreases from top to bottom. First, reaction with water. All group 1 metal reacts with cold water. Heating is not required. Why? They are highly reactive metals, so they will easily react with cold water. Heating is not required. So when a group 1 metal react with cold water, 2 substances are formed. One is metallic hydroxide, that is also called an alkali, and the second, hydrogen gas will be formed. So one question is about the observation. If you drop group 1 metal in water, in cold water, what you can see? You will see bubbles. Why? The gas is being formed. The apparatus will heat up because the reaction is exothermic. Maybe you can see fire, and definitely why? Because hydrogen gas is formed, and hydrogen gas is a flammable gas, and the reaction is exothermic, so fire can be seen. We have done this in the lab. Metal will float on water. Why? Because group 1 metals are always less denser than water, so they will keep floating, and you will see the hissing sound. They are very reactive metal. Now if you change the metal, for example in experiment 1 you have used sodium, and now you are using potassium, the reaction will become more explosive, more vigorous. If you are using cesium, it will further become more vigorous. So down the group, all these observations will become more intense. That is the reactions of these metals with water. Now look at some examples of the reactions of group 1 metal. Sodium react with water, what is formed? Sodium hydroxide, and you know that alkali plus hydrogen gas is formed. Now this is an alkali. So if you are going to check the pH value of the solution, it will be more than 7 because this is an alkali. And if you are using to use the litmus paper, it will turn from red to blue because the solution is alkaline. Now, how you can confirm that the gas is hydrogen? There will be two words used in the paper. One is test, the other is observation. How to deal with these words? What is the meaning of a test? Test means anything that you will use. It may be any chemical, it may be a pH paper, it may be a litmus paper, it may be a flame, anything that you are using. That is called test. We will use lighted splint. The gas is hydrogen, so you will listen a pop sound. Hydrogen is a neutral gas, it is a colorless gas, and it has no smell. Now reaction with oxygen. When group of metals react with oxygen, they will form metallic oxide, and these metallic oxides are basic in nature. Keep in mind, group 1 metallic oxide and group 2 metallic oxide, they are 100% basic. In the remaining group, there is a mixture, basic, amphoteric. This is how we can form. Now there is a common question about group 1 metal, that how these metals are stored in a lab. You have seen potassium, you have seen sodium. So how these metals are placed inside the lab? So definitely we are using oil and the cooking oil, okay? So they are placed inside the oil. Why? So that atmospheric oxygen and moisture don't approach these metals. They are not stored in water, they will differently react. They are not stored in empty bottles because then they will react with oxygen. The next group in this topic is group 7, and they are also called halogens. Their outermost electrons are 7, so they can easily gain 1 electron. So the charge for group 7 is 1 minus. All group 1 elements are non-metal. Now this is a table. We will discuss the names, the color and the physical state. Fluorine, it is a pale yellow gas. Chlorine, it is a greenish yellow gas. Bromine, it is a reddish brown liquid. You have to memorize. Iodine, it is a blackish blue solid. In the expected color and the physical state for S13, it should be definitely a black solid. Now just note down two changes. Look at the physical state. Fluorine is gas, chlorine is gas, bromine is liquid, iodine is solid, and S13 should be a solid. And look at the color changes. The fluorine color, it's a pale yellow. For chlorine, it is a greenish yellow. Bromine is reddish brown. Iodine is blackish blue. And the last one, S13, is black. So the color becomes darker down the group, and the physical state changing from gas to liquid and then solid. What it means? It means the intermolecular forces increases. Why I am using the word intermolecular force? Because these are covalent in nature. So these are the color changes plus the color changes in case of further details of halogens. Their melting and boiling point increases down the group. We have discussed that intermolecular forces also increases down the group. So their densities also increases down the group. They exist as diatomic. Diatomic means consisting of two atoms like F2, Cl2, Br2, I2. Now this is a common example of fluorine, F2. It has 7 electrons. so need one electron. And I have told you so many times that need and shared electrons are always equal. Fluorine need one electron, so each fluorine will share one electron for sharing, one electron from this fluorine, one electron from this fluorine, and they will form a single covalent bond, and this is fluorine as a diatomic molecule. Now some reactions of halogens in your syllabus. Halogens are reactive non-metal, but reactivity decreases down the group. In group 1, the reactivity increases down the group. In group 7, the reactivity decreases. So group 1 and 7 are totally opposite in their reactivity behavior down the group. Now displacement is a common reaction in halogens. Displacement reaction. There is one rule for any displacement reaction, that more reactive element can displace less reactive element. That is also in case of halogens, that more reactive halogen will displace less reactive. You have the periodic table. In halogens, down the group reactivity decreases, so fluorine is most reactive, then chlorine, then bromine, then iodine, and at the end astatine. You can see these types of questions in the chemistry paper. The table is mostly given. You will be given the halogen that we are adding, the compound that is already present in the beaker or in the solution. You have to write the reaction if the reaction is possible, and then write the color change. Now, if the reaction is possible, how we can identify the color at the end of the reaction? So just keep in mind, the halogen that has to be displaced, you will write at the end the color of that halogen. Now look at this reaction. We have sodium fluoride solution in the beaker, and we are adding chlorine. Chlorine is less reactive, so the reaction is not possible. You will just write crosses, no color change. Now we are taking sodium chloride solution in a beaker, and we are adding fluorine. Now fluorine is more reactive, so it will definitely displace chlorine. What you will observe the color change? Which element has been displaced? Chlorine. And the color of fluorine is what? Greenish yellow. So the reaction is possible. You can write like this and you will see this color. Now we have sodium bromide solution and we are adding iodine. Iodine is again less reactive, so there will be no reaction. When there is no reaction, no color change. You can also take remaining halogens. Now halide ions. When we are talking about halide ions, when any halogen gain one electron, if they have 7 electrons in their outermost shell, so they need one electron, and after gaining one electron, the ions will be called halide ions. Fluoride, chloride, bromide, iodide. Now bonding in halogens. When halogen react with non-metal, keep in mind, with non-metal, the bond will be covalent because they are also non-metal, and the bond between non-metal and non-metal is always covalent. For example, carbon tetrachloride. Carbon is also non-metal, chlorine is also non-metal, so the bond should be covalent. When they react with metals, for example, group 1 metal, group 2 metal, the bond will be ionic. For example, sodium chloride, potassium chloride. Now there is one common use of chlorine in the swimming pool or treatment of water. Chlorine is highly antiseptic. It can kill bacteria. So we are using chlorine in water treatment. Now we are discussing some properties of transition metals. What is the location of the transition metals? They are in between group 2 and group 3. You can see the periodic table. Their specific properties. First, physical properties. These metals are hard metal. You can see iron. Iron is a very hard metal. They are more denser. high melting point, it means the metallic bond is stronger in case of transition metal. And their chemical properties, they show variable oxidation state. What is the meaning of variable oxidation state? You can see iron with two variable oxidation state. The first one is Fe2 plus. This is also the oxidation state. Inside the brackets mean 2. You can see iron with 3 plus. Like copper is +1, copper is also is +2. So the oxidation state in transition metals are mostly variable. They form colored compound. This is another chemical property of transition metal. The color of the blood is red. There is iron. So they mostly form colored compound. They can be used as a catalyst. Later we will study about Haber process, contact process. Catalyst is any substance that just speed up the chemical reaction. Now the typical question about transition metals in group 1 metal. But read the question carefully. Maybe they ask about the comparison of their physical properties. Alkali metal versus transition metal. And maybe the question is about their chemical properties, comparison of their chemical properties. Please read the question carefully. If the question is about physical properties, then you can write their melting point, boiling point, density, softness, hardness, like that. If it's about chemical, then you have to focus on the reactions. So read the question very, very carefully. The last topic of this chapter is group 8. That's also called noble gases. The first point, they have complete outermost shell, maybe 2. In helium, there are 2 electrons in the valence shell. The remaining elements, they have 8 electrons in the valence shell. For helium, in the first shell, 2 electrons can be accommodated. So helium has the complete valence shell. The remaining element have 8 electrons in their valence shell. So their valence shells are already completed. They don't need to lose or gain electron. So the oxidation state is 0. They exist as monoatomic. Mono mean 1. They don't need any reaction. So they exist as a single atom. Single atomic forms are called monoatomic. We have discussed diatomic for halogen. Diatomic mean consisting of 2 atoms. Monatomic is for this group, and monatomic mean consisting of 1 atom. That's all about the periodic table.